Welcome to a new video. In this video we will continue to take a look at the properties of logarithms. We already finished the first 8 rules in our previous videos. Now in this one we will take a look at 2 rules. Actually one of them is derived from the other one, and these are called changing and switching of bases. And let's take a look at the first one, which is about the changing rule. Let's say we have a logarithm like logarithm of x in base a. That logarithm can be written as logarithm of x divided by logarithm of a. As you can see here, we do not have any base. In logarithms, if there is no any base, that means actually there is a base, which is 10. Okay, this is a different subject that we will take a look at in our upcoming videos, but at the moment just we can accept this as it is. So as you can see here, we change the base as 10, and now we can make it 9, of course. For example, this is also equal to logarithm of x in base 9 divided by logarithm of a in base 9. This is logarithm. And you can change this base to any number, but of course we need to obey here a rule. Okay, these are the rules that we have. It says a and b are positive real numbers. That means our base, okay, should be a positive real number except 1. Okay, except 1. So our base cannot be equal to 1 in this case. And this is, by the way, about rule number 9. Let me just write it here. So as a result, that expression, which is logarithm of x divided by logarithm of a in base 9, also can be written as logarithm of x divided by logarithm of a, and you can make the base, let's say, 100. Okay. Now from this point of view, we already know that if the base is e, let's say logarithm of x in base e divided by logarithm of a in base e, and then that number is called natural logarithm. So let me write it here. Logarithm of x in base a is equal to natural logarithm of x. We all know that a is a special constant. A is 2.7 and goes to infinity. So that the same expression also can be represented as, okay, let me write it here. If logarithm of x divided by logarithm of a, where the base is a, this is going to be equal to ln x divided by ln a. So ln here is the natural logarithm again. And let's take a look at a sample case also about rule number 10 as well. Again, let's say we have logarithm of x in base 4. Of course, you can think that, let's take a real number also for x. Let's say logarithm of 10 in base 4. We can switch the base, okay, in the following form. This is going to be equal to 1 divided by logarithm of, now 10 becomes base, okay, and base, which is 4, becomes the number. So in this case, you can also switch base and the number. These are, again, very useful properties that you may encounter in the logarithm questions. So we need to make practices to grasp the idea of those 2 properties. And now let's take a look at examples. Here we are asked to find the value of that summation. We have 3 terms. We can write this expression as logarithm of 2 in base 30, guys, plus. From a similar manner, we can say that this term that we have in the middle looks like it has a property about rule number 10. Logarithm of 3 in base 30 plus. From the same point of view, we can write this expression as logarithm of 5 in base 30. And this is equal to, guys. And if you realize here, we have all the bases which are same. So it's going to be 2 times 3 times 5, and now write the rest of the logarithm, which is logarithm in base 30. And this is equal to, guys, if you multiply, of course, 2 by 3 and then by 5, then we're going to have 30. So this is going to be equal to logarithm of 30 in base 30, and this is equal to 1, guys. And now let's take a look at the next example. We are asked to find the value of logarithm of 14 in base 21 in terms of a and b. Logarithm of 21, 14 is what? 2 times 7. So this is going to be logarithm of 2 in base 21 plus logarithm of 7 in base 21. So this is going to be equal to 1 divided by logarithm of 2 in base 21. Plus, similarly, we can write the following term, which is logarithm of 7 in base 21, as 1 divided by logarithm of 7 in base 21. From here, 1 divided by logarithm of 2. Again, 21 can be factored as 3 times 7. So we can write this term as logarithm of 3 plus logarithm of 7, where the bases are 2. Plus, similarly, 1 divided by logarithm of 21 in base 7 can be written as logarithm of base 7. Okay, 21 can be factored as 3 times 7, so it's going to be logarithm of 3. It's going to be logarithm of 3 in base 7 plus logarithm of 7 in base 7. Okay, we already know that logarithm of 7 in base 7 is 1. And logarithm of 3 in base 7 is given to us as b. Logarithm of b, here we have 7, but in the base we have 2. Doesn't look like a, but it's 1 divided by a actually. So this is going to be equal to, guys, 1 divided by logarithm of 2 in base 7, guys. And this is equal to what? 1 divided by, and our denominator is a. So this is 1 divided by a, guys. So I'm just putting it here, 1 divided by a. Now we have no clue about logarithm of 3 in base 2. But we can obtain 2 from here, and then we can obtain 3 from here in terms of a and b. From here, if you remember the logarithm rule, okay, from the very beginning, 7 were coming to the right. In that case, 2 is what? 7 to the power of a. Similarly, we can apply the same thing for b, okay. 3 was staying here and 7 was coming to the right again. So 3 is equal to 7 to the power of b. And now I'm going to benefit those two values, okay? I'm going to put them here instead of 2 and 3. So it's going to be 1 divided by logarithm of, now instead of base 2, I'm going to write 7 to the power of a. And instead of 3, I'm going to write 7 to the power of b. Plus, we have 1 divided by a here. Plus, we have 1 divided by b plus 1. And now this is going to be equal to, guys, you have b, 7 to the power of b. In the base part, we have 7 to the power of a. If you remember the properties again, we can write this expression as 1 divided by b divided by a times logarithm of 7 in base 7 plus 1 divided by a plus 1 divided by b plus 1. Okay, logarithm of 7 in base 7 is 1, so I'm just crossing this value. And okay, let me write the rest of the question at the very top at the right. So this is going to be equal to, guys, 1 divided by b divided by a plus 1 divided by a plus 1 divided by b plus 1. This is going to be equal to, guys, 1 divided by b plus 1 divided by a plus 1 divided by b plus 1. And if you remember here, we are dividing 1 by b plus 1 divided by a. This is going to be 1 times a divided by b plus 1. So it's going to be equal to a divided by b plus 1 plus 1 divided by b plus 1. And now denominators are the same, so we just add the numerators. So it's going to be a plus 1 divided by b plus 1, which is the final answer, guys. I'm going to write the final answer at the very left at the top, okay, as a plus 1 divided by b plus 1. I'm sorry it looks like a mess, but if you can follow what I did here step by step, then it might help you more. Let's continue with the next example. Okay, guys, this is our last question in this video. In this question, we are asked to find the result of this calculation, and we will benefit from the rule number 9. We can write the whole terms as following. For example, logarithm of 5 in base 2 can be written as logarithm of 5 divided by logarithm of 2. We can suppose that the base is 10 times logarithm of 3 in base 10 divided by logarithm of 5 in base 10. And again, if there is no base written, okay, that means there is a base which is 10. Just as a reminder, logarithm of 2 divided by logarithm of 3. And now in this question, we can easily cross out the same values, okay? For example, we can cancel this logarithm of 5 with this logarithm of 5. One from top and another one is from the denominator. And that logarithm of 2 cancels that logarithm of 2, okay? And similarly, that logarithm of 3 is gone with that logarithm of 3. In the numerator, we have 1 times 1 times 1 divided by, in the denominator, we have 1 times 1 times 1, which is 1 divided by 1, and which is 1, guys. That's it for this video. We will continue to take a look at the properties of logarithms. Thank you for watching and see you in the next videos.